Good morning, everybody, and welcome to this next session from the ALT conference. Hope you're enjoying the conference so far. I'm delighted to welcome Carlos Goller to present on this session. Carlos is an associate teaching professor at North Carolina State University, and his paper is titled Using Open Educational Resources and Technology to Empower Communities of Undergraduate Scholars. So, Carlos, the floor is yours.
Thank you. I'm delighted to be here and share with you what some of our students have been doing and how we've been using educational technology, open educational resources, and just the energy that students bring to create excitement and really promote learning and discovery, even virtually. So my slides are available. I created a short link to these Google Slides, and the link is go.ncsu.edu/Delphia ALT21. Okay, so I'm gonna get started with maybe. I'm gonna get started with my slides. If I can get them to. Okay, so I have a long session description that I don't expect you to read, but I kept here just to remind me that the focus of this was both discovery as well as using student energy to really catalyze more connections and more exciting projects with students and units on campus. And this includes the libraries, the student groups, and student courses. So I'll start with some session goals. I really would like us to learn about what students here at NC State did, how they created a virtual undergraduate research experience that combines citizen science and open pedagogy to connect multiple courses, people, and campus resources. And let's list a couple of potential modifications to this framework that will provide opportunities for more undergraduate students. So I'm really eager to learn how we can modify this and connect with different campuses to make it even bigger and better and more open. And finally, one of the session goals is to design potential modifications of the Delphia Project that can leverage open educational resources, citizen science, and student engagement. So the outline for this presentation is, I've been talking about Delphia, but I really haven't told you what Delphia is. So we'll start with what is Delphia Sidevorans, and for that, I'll talk a little bit about the history of how I got started on this. Then I'll talk about the Delphia Project and how students drove this project and how students modified the project and it evolved during our switch to remote emergency teaching. Then what are we doing next so that hopefully you can share ideas and we can connect. And finally, we'll ask, how can we learn and engage and empower moving forward? And this icon from the Noun Project is from a really fantastic illustrator and designer, Luis Prado, and it's gold panning. So this person is panning for gold. And this is really symbolic, and you'll learn a little bit more about how gold is related to this organism and how we've found some really nuggets of wisdom and student energy that have catalyzed what I really described as nuggets of gold and wisdom moving forward. So what do I do and teach? I teach molecular biology courses at NC State in a biotechnology program that serves the entire campus. So we have undergraduate students, mostly in their third and fourth year. We have graduate students, we have postdocs, and the occasional faculty member taking molecular biology courses, mostly with lab components, though I've been doing a lot of bioinformatics lately. So I teach something called high throughput discovery. And that in my world, the robots don't do the robot dance. They pipette liquids. And I came up with this idea as part of my job talk in 2015, transitioning from a teaching postdoc to this position. I really wanted to engage students in high throughput discovery and using automation to discover and collect lots of samples and analyze them. And this will come into play with how the Delphia Project evolved. I'm a microbiologist by training, so I teach a class called metagenomics, where we look at bacterial communities or microbial communities in odd places, your kitchen sink, the library on campus, and we analyze their composition, which microbes are there and what are they doing. And with my significant other, Dr. Claire Gordy, I teach a yeast metabolic engineering class where we look at yeast, your sourdough yeast, for example, and we talk about how we can engineer these organisms to make products. And the theme is sustainability. So engineering yeast to make products that will contribute to a more sustainable lifestyle. And I pitched before the pandemic, I pitched teaching a class called Biotechnology and Sustainability, whereas the three previous classes were for third and fourth year and graduate students. I really wanted to reach the first and second year students, particularly those marginalized students and transfer students, and really get them involved in high throughput discovery, yeast metabolic engineering, and metagenomics in the context of a semester long theme based class on biotechnology and sustainability and recycling electronic waste. So I'm mentioning this because, oh, my slides. I'm mentioning this because I really enjoy learning about microbial communities and how to harness their power. So for this, I don't have all the answers. I'm frankly new to some of the bioinformatics, and I want to co-create and learn with students. So for that, we've created a series of web pages, such as the one on the screen on the right. This is the BIT Biotechnology 477, 577 Metagenomics site. And it's a WordPress public site with student contributions. And these include podcasts, tutorials, video tutorials that the graduate students in the course make. So half of the students are graduate students. All students make podcasts describing their process or their samples or something interesting and interesting concepts. And we distill all this knowledge in class notes that are collaborative in something we call the meta book, a Pressbooks a platform book where students share their notes, and every semester or every course offering, we share notes with a broader public. And as part of my commitment for being open, I post all non-grade related items outside of our learning management system in the Meta blog. And this is one system I use for metagenomics. We do podcasts in this class, but for high throughput discovery, we do short lessons so that people can learn about drug discovery or microfluidics. in the yeast metabolic engineering course, Claire and I do case studies where students produce case studies and we post them on a WordPress site. And if for the biotechnology and sustainability class I'm launching in the spring, I'm hoping to get students to write public service announcements and videos that we can share with the public. So what is Delphia pseudovorans? That was a lot about me, but now I want to talk about this organism. So on the bottom right corner, you see a graphic we made about this bacterium in yellow, black, and orange. So Delphia pseudovorans, the first semester I taught the metagenomics class, Dr. Rob Dunn, someone who I admire, an author of several books and really interested in public science, and I were having coffee and talking about this class I was designing and what samples we could do safely. And he had just done a citizen science project where they had surveyed hundreds of houses around Raleigh and Colorado to look at the microbial communities in kitchen countertops, doorknobs, pillows, TVs. And I asked, what about the kitchen sink? So we laughed a little and then we said, that would be an interesting thing to do. So the first semester I taught the class, we surveyed kitchen sinks and we found in a graduate student's kitchen sink, Matt Moore, 60% of this microbe I had not known about before, Delphia pseudovorans. And it really intrigued me because Delphia looked like E. coli. So there's a plate on the right with Delphia. This was actually one of the first isolates we found when we were able to get the bacterium in the lab. And as that first class evolved in 2013, what was really intriguing about the kitchen sink having a lot of Delphia was that same year, a group in Canada had discovered that Delphia pseudovorans is able to take liquid gold and precipitate it out into gold nuggets. So now you'll learn about the gold nugget theme. So I became obsessed with this organism because I said, what is it doing in our kitchen sink? And it really became a catalyst to encourage students to learn more about the unique microbes around us. So it turns out we did campus-wide surveys with introductory classes that enroll hundreds of students. We gave them swab kits. We then processed the swabs in the high throughput discovery class and then analyzed the microbes in the metagenomics class. And we surveyed hundreds of sites around campus, including the libraries, to identify in our built environment where Delphia pseudovorans lives. And this connected classes and really empowered a series of a group of undergraduate ambassadors to connect the classes. So Noah Riley, Deja Norman, several undergraduates went to classes and said, here's what we know about Delphia. Help us learn more. Come use this swab kit, do a couple of online tutorials, and send your swabs in so that we can learn more about this microbe. And last year, Noah was the first author on this PeerJ paper describing this initiative. So what is the Delphia Project? So after learning a little bit about the microbe, we really were intrigued that not much was known about it, yet it precipitates gold. It may not make us rich, but it has really intriguing properties. So the Delphia Project became this WordPress site run by students, and I have a screen capture on the right, where we really wanted to learn all about Delphia. Student-led projects and driven by a community of scholars wanting to learn more about this and other microbes. And I provide a link to this student-driven WordPress site. And what we wanted to do is empower these students to be researchers. So with the help of the libraries on campus, learn more about search strategies, citation, and make connections with other classes and share knowledge. So we have a blog site that's student driven, in which we share research in an open and accessible way. The students are contributors, editors, and leaders, and they share data and interact with researchers, extension staff on campus, and the libraries. And their goal is to really engage and inform others. So, as part of the student blog posts, this is an example of something we did last year. We were unable to do lab work because of distancing and pandemic restrictions. So, a group of Delphia students really decided to use hypothesis to annotate papers and articles and learn all about Delphia. And they were systematic, so driven by Deja Norman and Lauren Ramillo. They had every 2 weeks, they would send out an email and say, this week we're focusing on this topic, Delphia as a pathogen, or Delphia to bioremediate contaminated sites. They took the Wiki EDU course to edit Wikipedia. They systematically annotated papers using hypothesis, the web annotation or social annotation tool. And at the end of the semester, they had a series of blog posts, and they edited the Wikipedia page for Delphia that had just a paragraph and 3 sentences. And Carlos was always irked that one sentence was factually incorrect. The students created about 7 pages worth of information and data. And beyond that, they presented on how they annotated, how they collaborated, how they edited Wiki to produce more comprehensive and accessible resources. So they did student readings or reading scores of the text before and after editing it, and the number of references added. And this is just a screen capture of the poster. So lately, I've been really intrigued by what happens to our electronic waste on campus. And that ties into the biotechnology and sustainability issues. Where do the screen you're staring at, or the mouse you have on your desk, once it's disposed of, what happens? So I've managed to convince a group of students, Rabea Tahir, Tanasha, Eunice, Raul, and Zainab, to look into, in the spring, what happens to our electronic waste on campus, and create a case study that would inform our campus and beyond. So this is a screen capture from the learngala.com website, where we can share case studies. And I want to just emphasize how detailed this is. They did background information, the ethics of electronic waste, the global market for electronic waste. Then they focused on North Carolina, and they actually tracked where our electronic waste goes. And what I really want to stress is Rabea was here in North Carolina, Tanasha was in Thailand, Raul was traveling back and forth from home in Raleigh, and they all worked virtually throughout this year to create this case study and look at what happens with our electronic waste on campus once it's put in those yellow bins you see on the top left corner. They reached out to waste diversion coordinators on campus and interviewed them. I encouraged them to make it accessible and include transcripts. They interviewed community development specialists, as well as companies involved in recycling of electronic waste. And we are going to make this case study public and use it in the BIT 295 biotechnology and sustainability class. next spring. And what really I love is the students in this group came up with take-home messages as well as pre and post quizzes to test student knowledge on this topic. And as part of an undergraduate research experience we did virtually with 13 participants from across the nation this summer, the Delphia group implemented this case study as a pilot run and surveyed students and did basically mini focus groups to learn how to improve this case study. So, what are we doing this semester? I am still really interested in electronic waste as we prepare for this class, and how Delphia seedivorans and other organisms can be used to mine our electronic waste. And as I mentioned before, maybe scavenge for precious metals in our discarded microchips, for example. So science in the classroom from the AAAS Society that publishes the Science magazine has something called Science in the Classroom. And Melissa McCartney and others have created this really great initiative where faculty and instructors annotate papers that have been published in Science and other journals, and then make it more accessible for students. So with students this semester, I'm getting help annotating papers with hypotheses that we can use in the biotechnology and sustainability course to really create a framework using the Science in the Classroom, a framework where they have lens of learning, glossary to define terms like bioleaching, and let's create a series of accessible documents or make studies more accessible for these first and second year students that will be part of the course in the spring. And that's
Carlos,
yes.
I'm going to have to bring this to a close now for your presentation in order to have time for Q&A.
Perfect. Yep, that's fine. So that was my last slide. This is what we are doing, and I hope to get some ideas for what can we do next and what can we do next together.
Thank you very much, Carlos. It was a fantastic presentation, and I always enjoy presentations that have humor in them as well as information. There was plenty of that there. Very interesting. I'm looking at the questions in the Q&A chat, and we have the first question is from Ricardo. What would you say were the best and worst aspects of the project?
The best aspects of the project?
Yeah, the best and the worst aspects of the project.
Okay, the best project is just letting students or empowering students to come up with their own questions and go into classes and give presentations and encourage others to participate. The worst has been we had lots of students really excited last year, and the pandemic is awful for several reasons, but it really limited what students were able to do in the lab, and it was tough to see their energy getting squashed.
Okay, thanks, Carlos. And the next question from Tea Time. Apart from the science side, what other skills were the students learning on this project? It's a good question.
Oh, excellent question. I would say science communication is one. They've actually worked with the Science Storytelling Club, with a couple of other clubs on campus to make their blog posts more accessible. And another skill that I think is really important is they worked with the libraries to make the documents open and accessible. And several students really resonated with how open and paywalls and how can we distill this knowledge and share it in blog posts, for example.
Yeah, I can see there was a lot of additional learning. there's lots of positive comments in the chat. I don't see any other questions here. I have. Sorry, okay. We're going to have to. I had a question myself, but I've been told that we now need to close. So let's just see. No more questions in the chat, but lots of positive comments. A lot of people have enjoyed that presentation, Carlos. So many thanks to you again for that, and to everybody who's participated in this session. And enjoy the rest of the conference. Thank you.
Thank you.